All right, here is your video for questions you all asked for on page 79. All right, number 55 is a little bit tricky. It's a piecewise function involving tangent. If that's not enough, they want to add an absolute value over here for our domain restrictions. Okay, so that changes things for us. So let me remind you a little bit about how absolute value inequalities work. For the top one with tangent, if the absolute value of x is less than 1, I used to stress if it's less than, it's an and. So and can be written as this between. So that's an and. It's between -1 and 1. And for the bottom one, for x, if it's greater than, it's an or. And so the first one is exactly the same, or you switch the inequality and you switch the sign of the value. So we have two numbers actually that we need to check. It's -1 and 1. So if we check -1 in the function in the top one, if we do tangent of pi times -1/4, we would just plug that into our calculator and see what we get. Well, actually, I don't want to get my calculator out, but -pi/4 would be here. Pi/4 is 45 degrees. So it's a 45, 45, 90. And that's -1 because it's below. So the tangent would be -1. And if you plug -1 in the bottom function, you would get -1. So these agree. And then if you check +1, whoops, in the tangent function, you'd get the tangent of pi times 1/4. So that's the tangent of pi/4, which is 45 degrees. So it's the 1, square root of 2 triangle. You can't see that. So 45 degrees. It's a 45, 45, 90. So these are both the same. These are positive values. So the tangent would be 1/1, opposite over adjacent. So the value would be 1. And if you plugged 1 in the bottom function, x would just be 1. So these agree. So we are continuous at +1 and -1. And since those are the only issues, then it is continuous. All right. Next, we'll do number 57, it looks like. F of x equals cosecant 2x. Well, that function has some issues. So if you would like to use your calculator for it, remember it's the reciprocal of sine. So you can do 1 over the sine of 2x. So you should be able to graph it that way. And we know cosecant has, we know it has discontinuities. We know it has asymptotes. And so, let me think. So, sine, I'm not going to graph this on the calculator. I'm going to try to graph it by hand. Sine of 2x. But that 2 is going to make the period. That's the b. So the period isn't 2 pi. It's 2 pi over b. So the period's pi. So we're going to go 0 to pi. This is 2 pi over 4, 3 pi over 4. And then we can graph with our amplitude. Oh, we used to love this. So everywhere that sine is crossing the, or is on the x-axis, we have asymptotes for cosecant. So cosecant is continuous in between the asymptotes, but at 0 and pi over 2, and at pi, which we could call 2 pi over 2, and then it would be again at 3 pi over 2 and 4 pi over 2. So it would happen at multiples of pi over 2 that we would have discontinuities. Even on the negative side, right? Even on the negative side. And these are non-removable. To be really honest, I know you all were asking why is it removable or non-removable. I'm going to try to look that up, but for the moment on these piecewise, well, this isn't a piecewise. This is non-removable because nothing factors out of it. Nothing cancels out. So that's what we'll say for now. The next one you all asked for was, looks like I skipped 49. I need to go back and get that. F of x equals the absolute value of x plus 7 over x plus 7. This is actually a piecewise, just kind of hiding in, is it a piecewise? It's a piecewise, hiding in plain sight. We know we have a discontinuity at -7. And if we would need to check the limit at -7, so this would be equal to the piecewise function of the negative well, that would become positive on the top. For I'm struggling setting this up, but 7's throwing me off. For x less than or equal to -7, and then the positive for x greater than 7. Let me stare at that for a little bit.